All right, team. I'm going to work through the review for the quiz. A lot of good problems in here. Let's get started. In the following figure, JORNS is a regular pentagon and RDNA is a parallelogram. So we had a pentagon and a parallelogram. The area over here is 396. NA is 12 root 3. Oh, I like that. I like that. And RNA is 120 degrees. What percentage of the figure is the parallelogram? So remember, percentage is the part you care about divided by the whole thing times 100. So the part we care about is the parallelogram. The whole thing would be parallelogram plus pentagon. And let's get to work. All of the information they gave us was on the parallelogram. So I'm going there first. If that's 120 degrees, then I know these angles are 60, 120, and 60. Parallelogram opposite angles are equal, and consecutive corners have to add up to 180. I could drop a height this way using that 60-degree angle, and I have a right triangle that is a 30, 60, 90. I know that the side across from 30 would be 12 root 3 divided by 2, so it's 6 root 3. And then the side across from 60 would be 6 root 3 times root 3, which would be 18. And what we have here is a base and a height. Remember, if you have a right, you have a height. No right, no height. Right, height. No right, no height. Do I have a right? Yes, then I have a height. And it is the height for this entire side, not just the 6 root 3 part. So what we know is that for a parallelogram, area equals base times height. We know the area is 396. The base we don't know, and the height we know is 18. 18 is the height for that base. So we divide both sides by 18. 396 divided by 18 is 22. That means AD, this length, is 22. All right. Well, it's a parallelogram, so this is also 22, and I can now work on my pentagon. On my pentagon, remember we draw that right triangle that's inside the shape. If the entire side's 22, this would be 11. So I'm going to work on it over here. This would be 11. Because it's a pentagon, how many of these would we have? We would have 360 divided by 10, 36. There'd be 10 of these things. 10 triangles would fill in a pentagon. So we get the angle at the top. 360 divided by 10 would be 36. I'm going to call this side A for apothegm. And you can do the trig, but I promise you it's 11 divided by tan, 36. So the formula is going to, we need the perimeter. If one side is 11, the perimeter would equal 11 times 10, or 110. So the area of the pentagon is 1/2 times the apothegm times the perimeter. That would be 55 times 11 would be 550 plus 55 would be 605. I'm going to make sure I got that right. 55 times 11, 605. Over tan 36. All right. So we need a percentage. I know I'm kind of all over the place. But over here, I'm going to do my percentage. We want to know, what was the question? Sorry. What percent of the figure is the parallelogram? So it's going to be the parallelogram, the part we care about, divided by the whole thing. That would be the parallelogram plus the pentagon times 100. So I'm going to type that in, hit the fraction key first, 396 over 396 plus 605 over the tan of 36 times 100 rounds to, it's 32.2, round to the nearest whole number, it's going to round to 32%. Nice. I don't know if there's another way to do that one, by the way. So, that's it. Find the area of the rhombus if AC equals 20. So if AC equals 20, and they tell us it's a rhombus, I'm going to go ahead and draw both diagonals. On a rhombus, it would cut this corner in half, making it 40 and 40. AC would be cut in half, That would be 10 and 10. And we want the area of the rhombus. So remember that the area of a rhombus equals 1/2 d1 d2. So the area of the rhombus is going to be 1/2 d1 equals 20. We need to know d2. So I'm going to work on the right triangle right here. I'm going to call this x, and I would know, so we have 40 degrees, opposite is 10, adjacent is x. That x is 10 divided by the tangent of 40. That means that d2 is 2 of those, 20 divided by the tangent of 40, right? Wouldn't d2 be the entire thing? So d2 is going to be times 20 over the tangent of 40. So that would be half of 20 would be 10, so that would be 200 divided by the tangent of 40. 200 divided by the tangent of 40, and I get 238.350. It says round to the nearest hundredth, so it would stop at 0.35. There we go. Number 3. Find the area of the shaded region. So the entire region is a sector. And part of that sector, the white space, is a triangle. So I'm going to work on the sector first. The area of the circle is 144. So we got to work with that first. Area equals pi r squared. 144 pi equals pi r squared. So the radius equals 12. So for the sector, we have 120 degrees out of 360 times pi times, or actually we already know the area of the circle. They told us, 144 pi. So the sector would be 1/3 of the whole thing, which is going to be 48 pi. Right? 120 out of 360, that is 1/3. So the sector, the entire sector, is 48 pi. So let's work on the triangle now. And that is an isosceles triangle because it's made of 2 radii. So working on the triangle, I have an isosceles triangle where it's 12, 12, and in between 120. Because it's isosceles, I can drop it like its height, and that would make that 60 and 30. Across from the 30 would be 6, and across from the 60 would be 6 root 3. Which means the entire thing is 12 root 3. So the area of the triangle is 1/2 times 12 root 3 times 6. So I drop the height, work on the 30, 60, 90 triangle, and we have 36 root 3. All right. So I have those 2 pieces. It says find the area of the shaded region. Well, that would be the sector, 48 pi, minus the triangle, 36 root 3. So 48 pi minus 36 root 3. And I get 88.443 is what it would round to. Nice. Let you look at that again real quick. 1, 2, 3. Find the surface area of the figure. Note you will have to find the slant height of the cone. Round to the nearest tenth. Ignore the black line on the right. Couldn't get rid of, oh yeah. Get out. All right, so we have a cube, 6 by 6 by 6, and we're talking about surface area. We have a cone cut out of the cube. I've tried to explain this in class the best I could. But if this was not here, if this was filled in, we would just have a cube. And I'm going to pretend that's the case. So my plan is going to be the total of the cube. Here's the thing. This circle is not actually there. But when I do the total of the cube, it includes it. So I do have to do minus the circle. And remember, when you cut a shape, you expose the insides. Those are surfaces now. So like the cone here, the base is not there, so we subtract it. That's the circle. But what is everything but the base? What's the rest of this? You could see and touch the rest of it. That is the lateral part. We need to add the lateral of the cone. That is a new surface. So we lost a circle when we made this cut, but we gained the lateral part. So the cube, the surface area would be, there's a few ways you could do it. You could do pH plus 2b, but also just think about it like this. Isn't this 6 times 6? And then isn't that, and aren't there 6 of those? How many squares are there? There's a front, back, left, right, top, bottom. So there's 6 squares. Each of them have a surface area of 36. So you could do it that way as well, which is going to be 216. So the entire cube with no issues is 216. The circle would be pi r squared, which is pi times 2 squared, which is 4 pi. And then the lateral of the cone, the lateral of a cone is pi RL. So we're going to have to work on that. They even told us that in the hint, remember? So if I were to draw the cone standing up, it would look something like this. We know the radius of the cone is 2. So we got that. We have the radius. We do not know the slant height, but we do know the height. Wouldn't it go from the top all the way to the bottom? Well, what is the top to bottom distance of the cone? The top to bottom distance of the cone is 6. So there's a right triangle here of 6 and 2. Reduce those, that'd be 1 and 3, that'd be 9 plus 1, that's a square root of 10, times 2 would be 2 root 10. So the slant height is 2 root 10. So the lateral is going to be pi times the radius times the slant height, 2 root 10. So my final answer is the cube minus the circle plus, what would that be? 4 pi root 10 plus the lateral. So 216 minus 4 pi plus 4 pi times root 10. And I get 243.17, and if I round that, it'd be 243.2. So that's the right answer. That's a nice one. Find the surface. Oh, look at my friends here. Look at my friends here. It's kind of blurry here. Sorry, but that's Nisha and Isha, Carly and Nitty. They're pretty awesome. All right. They're a lot of fun. So we have this shape. It says find the surface area of the figure. All right. Tough stuff here. Need to come up with a plan. Here's the issue. This blue rectangle that I just tried to draw is not a surface. So I am going to do the total of the box, but I am going to subtract that rectangle. Why? When I do the total of the box, it includes that rectangle, but that rectangle is not a surface. So it's gone, minus the rectangle. And then I'm going to do plus the 2 bases of the triangle pyramid, or prism, plus the 2 rectangles I can see, right? I can see the right side, I can see the left side, but I can't see the bottom. So I don't want to include the bottom. If I included the bottom, I'd have to then subtract the bottom. So that's my plan. So let's start with the box. Surface area is going to be pH plus 2b. I'm going to make the bottom my base. So if I'm working on the bottom, that would be 19 by 9. So that'd be 19 plus 9 times 2 would be 56. So the perimeter, I'm going to put it over here actually. The perimeter is 56. 19 times 9 would be 171. The area is 171. And the height in this case would be 11. So it's going to be 56 times 11 plus 2 times 171. 56 times 11 plus 2 times 171. And I get the total of the box to be 958. Okay, then I'm going to work on this one rectangle. And we got to figure this out. So I know the entire bottom is 19. I know that this much is 5 and this much is 4. That means that this must be 10. And I know from front to back it's 9. So the rectangle in question is 10 by 9, which means its area is 90. Okay, got the rectangle. I'm going to subtract that rectangle. Now I need to get the area of the triangles. I need the two triangles. They're the same size. I already have those numbers. The base is 10 and the height is 12. So the triangle is going to have a height of 12. They gave us that, and a base of 10. So that area would be 1/2 times 10 times 12. And that's going to be 60. Okay, so we're making a lot of progress here. Then we have to add the two rectangles that we can see. And they are going to be 13 times 9. Right? That front to back distance is still 9. So there's two of those, and they're both 13 times 9. So the two rectangles are going to each be 13 by 9. So 2 times 13 times 9 would be 26 times 9 would be 234. All right. So my final answer is the box 958 minus the rectangle 90 plus the two triangles 2 times 60 plus the two rectangles 234, which I already multiplied that one by 2. And when I get all that, I get 958 minus 90 plus 120 plus 234, and I get 1222. Nailed it! A lot of stuff there. That's a really good question. Yeah, I like that one. Find the surface area of the figure. The right and left side of the prism are squares. Man, that doesn't look like a square. I know. Calm down. I know. But it is 7 by 7. You just got to trust. It's a square. Find the surface area of the figure. Okay. So, okay. Strategy. We have a box with a cylinder cut out of it. We need to account for every surface we can see and touch. So if I do the total of the box, I'm including the circle on the right and this one on the left that are not there. If you were to draw the net, you would have 1, 2, 3, 4, 5, 6 rectangles, and 2 of them would have holes in them. You have to eliminate those 2 circles. So minus the 2 circles. They're not there. But what is now there? If you were holding this box, could you see and touch this lateral part of the cylinder? Yippers. Plus the lateral of the cylinder. So the box minus those 2 circles plus the lateral is going to be our area. So let's work on the box. The surface area of the box is pH plus 2b. I'm going to make the base the right side just because the cylinder is going left to right. Remember, with rectangular prisms, you get to pick the base. But I'm going to make the base be the 7 by 7 side. So the perimeter would be 28, and the area would be 49, and the height, how far is it from left to right? Well, according to this, it's 10. So the height's going to be 10. So the area of the box is pH 28 times 10 plus 2 times 49. 28 times 10 plus 2 times 49 is 378. So there's the box. The 2 circles. Let's work on the 2 circles. The radius is 2 Area of a circle is pi r squared. So that's just pi times 2 squared. That is 4 pi. So the circles are going to be 4 pi. And then the lateral of the cylinder is 2 pi RH. So that's going to be 2 pi times 2, but the h part is 10. So that's going to be 40 pi. So the final answer is 378 minus the 2 circles plus the lateral. So it's 378 plus 36 pi. And I get, uh-oh. There's always one I mess up on. Be quiet, Nisha. Either I was wrong before or I'm wrong now. I can't read my own handwriting. That's a 10. So let's go back. So the base would be 7 by 7. The height is 10. Let me erase all this junk. The radius is 2. So the air, 2 circles. I just did 1 circle. There's 2 of those. So 2 of them, 2 A's would be 8 pi. So it's minus 8 pi. So that would be 32 pi. Let's try that one, please. 378 plus 32 pi. Now I'm liking it. 478.531. Okay. Yep, 2 circles. I subtracted 1 circle. Oh, man. I'm a silly Billy. The drawing ones, do your best. All right. If I was rolling this up, blue would go here, green would go here, orange would go here. So the red edge would line up with the orange edge. The net would create, well, that's a 1, 2, 3, 4, 5, 6 hexagon. Those are triangles. That's going to be a hexagonal pyramid. The linear dimensions of a rhombus are tripled. What's the effect on the area? The area of a rhombus is D1, D2 divided by 2. If they're tripled, it would be 3D1 times 3D2 divided by 2, which is 9 times D1, D2 divided by 2. So it'd be 9 times bigger. The apothem of a pentagon is cut in half. What is the effect on the area? The area of apothem is 1/2 AP. The area would be 1/2 times half the apothem times P. So that would be 1/2 times 1/2 AP, which is half of the original. The original one is 1/2 AP, so it's half the original, 0.5. The base of a parallelogram is 1/3 the original, but the height is multiplied by 12. So the original is base times height. The base is 1/3 the original, so now it's 1/3 times the base. The height is times 12. So 1/3 times 12 is 4 times base times height, or 4 times the original. Pyramid A and Pyramid B are similar. What is the surface area? So if they're similar, that means that ratio, which reduces to 2/5, must be true the whole time. So because we're working with area, we have to square the ratio. So it's going to be 4 over 25, that's the small over the big, equals x over 600. The 600 we know on the big shape. We can reduce horizontally, so that would be 1 and 24. So 25 times what? Wait. I'm really confused. Oh, no. Okay, that'd be 3/5. That'd be 9 over 25, and that would be 600. Okay, that's 1 and 24. 25 times 4 times 6. 24, yep. So it's 9 times 24, 180 plus 36. Got it. Got it. Light work. All right, that's the end. Hope you enjoyed it.